Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss about data files. This is what we have discussed so far, that a Oracle server consists of an instance and a file systems, and there are different types of files in the file system, and those different types of common files are like this. And in this video, essentially, we are going to discuss about data files. All right. So data files are those files where your data where your data are eventually going to be stored. Say for example, I am going to write a insert statement where I'm inserting into, let's say, my table T. Insert into table, so let's say table T. Okay, and I'm going to insert some values like 1, ABC, and so on. So these are called data, and these data are going to be stored in a file, and that file is called a data file. Okay, so 1, ABC, and so on. So whatever the way that I'm shown is not like that. You may have thousands of data files. All right, and inside that data file you may have one data file may consist of 2 gigabyte of space. So how you are going to organize this number of data files, and how data are going to be organized inside a data file, that's what we are going to learn in this video. Okay, so for example, in my system, my data files are something like this. So essentially these are my different files, out of which I have apex, this one, sysux, system, and users.dbf are the example of data files. This is a control file, this is a temporary file, and this is undo file. We are going to discuss those things in our next videos, but in these videos we are going to discuss how these data files are going to be managed. All right, so this is how this is what we are going to learn here, is that how to organize this data file, and how data are organized inside the files. So let's start with a very simple example. Whenever you do, say, create table T and say a number, this is a very simple SQL statement, which is a DDL. I'm trying to create a table T. What this is going to do is that whenever I want to create table T, I'm going to Oracle is going to create a storage unit, and that storage unit is called segment. Let me write it down. Okay, that means for any object that is going to consume some storage, one segment must be created for that. Okay, so table T, and this is table T's segment, and this segment will have an initial size that is also given at the time of create table statement. In this case, I have not given those parameters. If I do not give those parameters, then Oracle is going to take a default parameter. Let's say, assume that default parameter in our fictitious case is 2 MB. That means a space will be allocated, a 2 MB space will be allocated for the data which is going to be inserted to this table T. Let's say this is 2 MB. Okay, so this is the storage segment. Segment is nothing but a storage unit. Then what we're saying, that these segments contain multiple extents. That means you can think this segment as, let's say, 2 extents. Again, I'm assuming that one, and each extent is of 1 MB. Okay, so these are called extents. So these are called extents. So in this case, this segment is consist of two extents, and extents is basically a contiguous space allocation. This 1 MB is contiguous, then the second extent may be near the first extent or may not, or may be very far away from the first extent. So the thing is that inside the extent the memory allocation is contiguous, but there is no such things that the extents should be near to each other. Okay, they may be far away. Then these extents are consist of things called block. That means inside that extends, what we have is the blocks. Okay, so what we told that whenever we are going to create a table, a segment will be created, and a segment is consist of multiple extents, and extents are contiguous space allocation, and extent is consist of number of blocks. So first is segment. Segment is consist of multiple extents, and the lowest unit is blocks. Okay, so let's discuss what is there inside a block. So your block is going to look like this. Okay, the block is going to look like this. It has a space allocated inside a block, that is called header. Okay, or this is called block header. So header typically contains what type of block is this, right? This means, is this block we are going to store table data, or inside this block we are going to store index data, or inside this block we are going to have a PL/SQL procedure. Okay, so what kind of data this block is going to store, we put that as a header. So header tells me types of block. Number two, if there is any transaction that is going on right now, that means let's say this is a table block, and then for that table I'm let's say doing an update. That means I am currently on a transaction, so transaction information. Then number three is that where this block is located in a disk, because finally this block is going to be in the hard drive, right? So address on disk. Then we have some space allocated, and that space allocated for called table directory. This is an optional space. If this block is a table block, then it contains the name of the table whose data are there inside this block. Then number three is going to contain row directory. So let me just write in another color. So it's going to contain row directory. So that means, like in this block, essentially what we have some data. Let's say we have one row here, second row here, and so on and so on. Okay, so what is the row address? So what is the address of this row? Those things are going to be stored in the row directory. So this is a first address, and whatever the address is this is going to be stored here. That means from here I can point to this row, from here I can have a pointer to this row, and so on. So row directory contains the address of the rows that is exist in this block. Then we have data, like those king, or like whenever we are going to insert that one in our first example, and whatever those data are going to be stored here in forms of row. Then I have some empty space. Those empty space I just kept this thing for some future updates. or if you want to insert and so on. Okay, these three together, the header, table directory and row directory, called block overhead. Essentially, block is one where we store data, and then inside this, in the block overhead, we store metadata about what things are going to be stored inside that block. Okay, so if this thing is now somehow clear, that let's go back to our previous slide. So that, so we, whenever we do a create table I, and then this is how it is going to happen, right? Then all these segments, extends and block, they are put together in a container, and that container is called table space. Okay, so table space is something which contains all the segments, extends and all this thing. So let's take another example. Let's say I have a table T1, table T2, then I have index I1 and then index I2 and so on. So whenever I create table T1, I will give what is the table space that I'm going to have this table T1. Okay, so let's say the table space is TA. So this is our table space and TA, right? So this is a table space TA. So I'm telling that T1 is a part of table TA. That means a segment will be created inside here, and that is T1. So T1 table, let's say T1's table segment name is S1. Okay, and table T2 is again is going to be part of table TA. So therefore this is table T2's segment S2, and then similarly index I1 segment, index I2 segment. This segment is basically essentially consists of what? Consists of number of extents, and number of extents inside in terms consist of multiple blocks. Then what we say that this table space A is associated with this file called 1.dbf, or whatever you are seeing here, in my case say sysox.dbf or users.dbf, right? So what you are saying that users.dbf is a physical file, and are you seeing table space? You are not going to see. This is a logical structure. Okay, so what we are saying is that users dbf, whatever you are seeing the physical structure, visualize those things, that users dbf may be a part of a table space TA. Okay, then what you are doing, that table space is basically a container, and is going to contain multiple segments and multiple extents and so on. Let's say if this is a case, then what we have, we are trying to insert into T1. We want to insert into T1 some values. Okay, so whenever you insert into T1, so T1 is basically part of this segment S1, and inside that S1 we have a extent E1, and inside that extent E1 we have a block called say B1. Okay, so this is a block B1 which have the overhead and then some place to store data. So to start with, all these things are empty because I just created table T1, I don't have any insert. So whenever I insert into T1, let's say I insert first value, then what essentially I am doing, I am filling this area in the block. That means I am filling the extent, that means I am filling the segment. What is happening actually? Actually there is some data is being stored in users.dbf, that's all. And then how we are visualizing that? We are visualizing that one in this, all this thing. Why you are doing that? That's a different things for that. Okay, that's a, we need to visualize in this way so that things will be much easier in later on. Okay, so here is a case. So whenever I'm going to insert into table T1, something happened. Then I'm going to insert another row. Then here another row is created. Eventually this block is going to be full. When this block is going to be filled, then we have one block in that extent is filled. I'm keep I'm keep writing this insert. Okay, so I'm just still keep going on inserting. Then what I'm going to eventually, I'm going to fill the extent. Okay, so what we started that whenever we have created table T1, we have 2 MB segment and there are two 1 MB extent, and we just filled right now one extent. Then we have another extent somewhere there, because to start with we have 2 MB, right, two extents. Then we are still inserting, so we are going to fill this extent. So we are filling extent means you are filling blocks, that means you are consuming place in this user.dbf file. Let's say this user.dbf is 2 gigabyte. So we are now consume only 2 megabyte. Then after consuming 2 megabyte, we have completed we have completely filled the two initial extent that are started while creating this table T1. Then what's going to happen? Oracle, then for the next insert, I don't have any space in my existing extent. What Oracle is going to do, it is going to create another extent automatically for you. That means a lot of blocks, that means a lot of areas where I can keep inserting. Then I can keep insert. So let's say we assume this thing that this is a table space. So we are basically we are keep inserting. So let's assume that in once this extent is filled, we are going to fill another 1 MB. So we are completely filled right now 3 MB. Eventually, what we are writing? We are writing to this file users.dbf. So dbf initially started with 2 gigabyte, and initially after this operation, after 3 extent, I consumed 3 MB. That means I have left with 2 gigabyte minus 3 MB of space. But eventually, if I am going to insert, eventually I am going to consume all this 2 gigabyte. If I am consumed all this 2 gigabyte, the dbf, the file is completely full. That means I have multiple extents, so on I have created, and then and so on inside that segment. Okay, inside that segment I have multiple extents created, and then basically I filled all this 2 gigabyte. Then if I want to still insert, then whenever I'm going to allocate a new extent, it's going to give me an error because I do not have any physical files anymore. In that case, what you can do, you can add another data file to this tablespace TA. That means you put some new disk to your machine, and then you create another file, say called user1.dbf. So what you're going to do, you are going to have another data file called users1.dbf. You associate that to your tablespace TA. Let's say here is another 2 gigabyte. Right, then same thing, if the insert is still going on, so I'm going to keep filling this user1.dbf, then so on. I can add and do whatever I want to achieve. So this is how your data files are arranged, how data inside the data file being arranged. So let's summarize everything right now. So basically what we are talking is that the minimum unit of storage is a block, and multiple block consist of an extent, and multiple extent together consist something called a segment. We have one segment for each database storage object, and all these things together put into a container. That container is called tablespace. Okay, and tablespace is associated with a data file. Another thing, that one tablespace can also consist of many data files, and that data files we can add dynamically whenever we are finished with the when you filled the complete the existing data files. This is what we are seeing is called logical storage structure. Okay, logical storage. Whatever you are seeing in this side is physical storage. Okay, again This physical storage can be a cooked file system. That means whatever I show you right now, this is a cooked file system. Under DBF, basically I'm this operating system file system. Okay, or it can be directly lie on the disk. That's called direct access. Or it can be an ASM based file system, or it can be a cluster file system. Don't worry about this thing. We have given you example here to the cooked file system. We are going to build on all the other things in the next chapters, but from user point of view, it does not matter how what kind of physical storage, what kind of file structure is that. But from user point of view, it matters that it's stored in this logical structure, and whatever applicable with the cooked file system, all those things are applicable for other things. So essentially, don't worry about the different how this is physically stored, but understand what is the idea, the rationale behind data files. Thank you.